yourself. I first. I'm Zhang Guangbin from E7 Research in Beijing. We focused on data center and cloud infrastructure research at CMI.
This is Siamak Tavalai. I'm a principal architect at Microsoft Azure. I have the privilege of being the co-chair of the server project as well. It's been great to be part of OAI subgroup.
Another people. Yeah.
Hi, I'm happy to introduce myself. I'm Rob Oper. I'm Chief Platform Architect at NVIDIA Data Center Products. It's nice to see some old friends on the video stream here, so glad to be here.
Well, my name is Vangel Bojaxi. It's my pleasure to be in this OCP Open Accelerated Infrastructure panel discussion. I joined INSPOR 4 years ago. Currently, I'm holding the position of Global AI and HPC Director. Prior to this, I served as a Principal IT Solution Architect of Schlumberger for 20 years, where I did large HPC high-end visualization system for seismic data, et cetera, in oil and gas industry. Currently, in addition to my role with INSPOR, I'm helping in Asia supercomputing community as ASC Executive Director.
Hi, everyone. I'm the hardware architecture of Minton. I'm mainly responsible for research in the selection and architecture of new server systems, such as next generation fusion server, liquid cooling, especially cold plate and GPU server systems, including self-development servers. So I'm very glad to meet you and discuss today's topic about Project OAI. Thank you.
Yeah.
Everyone, before we begin, we are getting a slight echo from a few folks on the panel. So if you wouldn't mind going on mute whenever you're not speaking, I think we can reduce that.
Yeah.
Michael, maybe you can disable Guangbin's accounts there, like just mute if they're sharing the same one.
All right, let me introduce myself. My name is Song. I'm with Intel. I'm the system architect for the AI architecture. I'm glad to be here today.
Guangbin, I believe the problem is not only the speaker, but also the microphone. So if you have two laptops next to each other, please turn off the speaker and the microphone of one of them.
Now let me begin. Yeah, my iPad have a little problem. Sorry. Okay. First question is moderator to moderator, as known as M2M, but not machine to machine. It's about machine learning. Please let me introduce OAI, OAM first. OAI stands for Open Accelerator Infrastructure. It's a sub-project of OCP server project, which include a set of standards, such as OAM and UBB. OAM stands for Open Accelerator Module, to unify a class of accelerators in mezzanine form factor. Compared to traditional PCI CEM form factor, OAM supports more power for more performance, technically providing interconnect between multiple accelerators. targeting larger and more complex machine learning models. UBB is a OS universal baseboard to carry OEMs. It provides protocol agnostic interconnects and supports heterogeneous OEMs. Today, OEM has become a high-end AI accelerator standard. So, Mark, this question is for you. Since you are one of the initiators who standards OEM and OAI, my first question is within less than 2 years, OAI become the industry standards for mezzanine module class accelerator. How did this work? Hi, Mark. Mark?
CMAC, you may be talking on mute. CMAC, I think you're on mute.
Mark? Hi. Hey.
Michael, as your host, are you able to unmute CMAC?
Unfortunately, I can only prompt him to unmute, which I'm trying to do, but he has not responded. If you need, oh, no, there we go. Hey, CMAC, I think you're back.
Okay, very good. Sorry, guys. We need to learn through this. It's been great being part of OAI subgroup. As you guys know, we started this one as an OAM project, Open Accelerated Module project, but very soon we realized that we needed to build a system around that. And what happened next was that a lot of smart people got together, and that was the magic. Working with OCP, open community, OCP provided a forum for us to have open discussion, understand the real problems, and try to solve the problems together. And the approach that we took, as Guangbin suggested, was a modular building block approach, in that we clearly define the boundaries of each module with clear input and output. We allowed each company or innovator could invent something new and bring it back to the team so that the modules still are interoperable. So that was basically the magic. The magic was understanding the need, bringing smart people together, and creating a win-win opportunity for all of us, basically, so that the end customers benefit from it.
Okay, thank you, Mark. The second question is for end users and vendors. As a representative of end users, Zhongping and Mark, what trend do you see the machine learning workloads are moving to? Zhongping, you can first.
Yeah, our GPU application scenario is still traditional training and influence, but the training model data is getting bigger and bigger, and the demand of our GPU server grows mainly in recommendation. Not only to expand the scale of the existing business, but also to effectively support the landing of the new business. The recommendation has high commercial value, but the collaboration requirements for cluster computing power are very high. So we have met a real pain point. On the other hand, different from general server, the single machine computing power of a GPU server is increasing quickly. On the other hand, the output capacity of the whole machine's computing power grows slowly. One more collaboration computing power is needed. Single point performance can be used at all. Just like a Ferrari driving on a muddy road, it's not feels good. Yeah.
Okay, thank you, Zhongping. And CM Mark, you also as a end user. Can you talk about your viewpoint?
Right, very good analogies. As you guys know, there are many smart people in the world these days coming up with different algorithms, different solutions, different frameworks. And a lot of these machine learning models require different accelerators, different interconnects. And in response to that, again, very many smart people come up with solutions that are different from each other. So placing all of these very varied solutions into the same data center has always been very difficult for us and challenging. When we really, really like and love a particular hardware solution, placing it into the data center, running it through the qualification stream, and managing using our own tools take a very, very long time. Several months it takes to place a solid platform into data center. So the solution that was needed for us was a method so that a standard data center interface basically be developed, the solution or mechanical interface, the thermal interface be standard, so that the internal guts and in the internal machinery can adapt to the different workloads that people require and different solutions that accelerators and interconnect solutions are providing. So that is basically the impetus for having a standard, a modular building block standard around accelerator engines.
Yeah, thank you, CM Mark. The next part is for Rob and Song. And from accelerator solution providers, what is the trend of AI accelerator solution in terms of power, performance, and scalability? Who can first? Rob?
Yeah, that's a great topic. On the last generation of accelerators, we were with the Voltas V100s. We were building 8 GPUs, each one about 300 watts, and then the current generation, the A100s, which are now in production in quite a few data centers, are 400 watts per device. There's still 8 GPUs per board. And we see that rate of increase progressing, and we've been giving guidance for substantially more power per device in the next generation. And if you step back and think about the process node changes and the size of the dies that are often used in accelerators, there's a tremendous number more transistors per generation. And so if you're actually utilizing the silicon, the power will go up substantially. So it shouldn't be a surprise that we're seeing an increase in the density of power. And that correlates to a really difficult problem in both delivering the energy to the devices and the rack, and also removing the heat. And so that's one of the real big trends, is going to be removing the heat. And it was really interesting seeing the previous talk on liquid cooling. I think that's an inevitable trend. If I think about scaling, we're looking at, we've historically gotten maybe 3 to 5 times the performance from every generation of GPU. on AI workloads, but the actual workloads are increasing more like 10 times every year. So the workload requirements are expanding far faster than we can even architect new systems. So you know, what's happening because of that is clusters are growing, they're becoming bigger, and it's now, it is, as crazy as this sounds, it's not unusual to be talking to people building many thousand GPU clusters for AI training. And I think we'll see this kind of trend accelerate.
Yeah. Thank you, Rob.
Yeah.
And the song.
Very good.
Yeah.
As we see, there are several challenges, either from the end user or from accelerator suppliers. There have been many challenges, but in response to those challenges, people come up with ideas how to build systems. Angel, would you please share with us some of the challenges that you have seen in building systems around these solutions, and how you have gone through facing and challenge?
Yeah. The song.
I think that's a great question. So, you know, I think Wanru is still trying to fix out his audio. Sorry. So maybe Song, we can continue your, you know, your feedback to the answer, and meanwhile, then Wanru will fix his.
Yeah, sure.
Thank
Okay. So I think as Rob mentioned, right, I think with the process node moving from like 7 to 5 and then to 3, right, I think the performance of the accelerator, right, is going to be quadruple, right? It's going to be very fast. With that, I think it's the same issue that we're going to see, right, in terms of the power delivery. We're going to need more power. And one of the major requirement, right, is the module interconnect bandwidth. So I think with the performance increase, I think the SerDes port, right, or the higher SerDes speed rate, right, it is going to be playing an important role, right, to keep up with the performance requirement for the OEM. And I also can agree with the Rob that the cooling solution is going to be moving from air cooling to liquid cool, right? And because the OEM is such a power hungry, right? And then we are looking into, like, for UBB point of view, right? We're looking at eventually there is going to be more than 700 in the next generation. So for the work stream, right, there I think we are also going to look into, like, what about 1,000 watt? Like I think Xiaomi mentioned that before in the work group. So this is something that is going to be the training of the OEM. And another thing is for the scale up, right, and the passive copper cable, right, that we try to use in the 1.0 for the 5060 PAM4 may be a big challenge, right, for the 112 gig. So the trend that I can see in the the OAI system, right, is going to be optical connectivity, and for the next generation as well.
Hey, could I just comment on that really quickly? I think Song really stated that well, and I wanted to sort of sum it up and say, if the workloads are expanding at 10x every year, then all of these, all of the different metrics in designing a systems will be stressed. So we need substantially more performance from the accelerators, you know, substantially more bandwidth between devices and between systems, and you know, substantially more cooling. It's just there's no way that fundamentally a piece of silicon can keep up with 10x per year demand. So systems get bigger, they get more power consumptive, and the I/O increases on an order of magnitude basis as well.
Well, I'm back. You know, sorry for you know, I couldn't figure out why my microphone was mute. But anyway, I guess you can hear me okay, right? Yes?
That's one of the reasons that we need to be in Prague right now, all together.
That and the beer is very
Summit
good.
was scheduled to be in Prague this year.
Okay, so I can try to answer your question. So to start with, I want to say that INSPO regards OAM OAI as a very clever response to the major trend in artificial intelligence, where the development of AI models and algorithms are triggered the exponential increase of the demand for higher computing power. Rob just made a lot of comments on that. I totally agree with that. So to increase the performance, naturally, first, we need to use faster hardware accelerator of more exotic technologies. And second, need to avoid unnecessary data movement by processing them in parallel within accelerators layers. With a modular approach and clear-cut interface standardization, like Simak discussed, OAM-OI design can achieve just that: low latency, high performance parallel data transfer, and accommodate separate scaling of different high performance accelerated technologies of different life cycles, like GPUs, FPGAs, TPUs, and maybe eventually quantum-based accelerators. Maybe I'm putting something for the future. So I see from Michael that there are more than 50 people, attending this panel discussion. So and a lot of people probably, they know all about NVIDIA and Intel and Microsoft, so maybe not as much for INSPOR. So I thought to say something about INSPOR so the audience have a better understanding. I want to say something about INSPOR cooperation in the industry and its contribution to the open community. So with the joint development and manufacturing, JDM strategy, INSPOR has been quite successful to establish the bridge and cooperate with CPU and accelerator vendors like Intel, NVIDIA, and big customers like Baidu, Alibaba, Tencent to engineer innovative, customized, economic, and world-class AI and HPC solutions. At the same time, INSPOR has been an ardent contributor to open technologies, particularly for OCP, where as a Platinum member has released more than 10 products since 2016. On the other hand, INSPOR has positioned itself as an early adopter of AI, and now just in a few years as a global manufacturer, INSPOR has been fully engaged in design and development of a full AI stack solution. It includes a comprehensive computing platform, the most advanced server hardware technologies, a complete management and performance suite, many modern deep learning frameworks, carefully optimized to deliver end-to-end agile, cost-efficient AI solution for its industry customers in many verticals. These achievements have propelled INSPOR AI market share in China to more than 51%, much higher than the other domestic and foreign competitors in the country. Gartner has recognized INSPOR for being China's largest server manufacturer and one of the top 3 across the world. The biggest advantage of INSPOR's solution is that it helps business become agiler and keep pace with its evolving needs. Now, leveraging both on its OCP and AI accomplishments, INSPOR has been able to be a front runner in releasing the first 21st-inch OAM reference platform, which was demonstrated in 2019 OCP Amsterdam Summit by OCP CTO Bill Carter, showing the INSPOR Universal Baseboard, UVB, and for Open Accelerator Interface OAI, with low latency 6-port hybrid cube mesh or fully connected scale-out topologies. We're happy to share that this way we are confident to meet the challenges we face with the proliferation of accelerators and the innovation needed to be successful in this new era of AI renaissance. Specific for AI, we see that the development of the new AI models and algorithms, with the developments of the new AI models and algorithms, the demand for high computing power is increased exponentially, as just discussed. Now, it's not unusual, for example, that OpenAI third generation language generated GPT-3 can handle 175 billion or more parameters, and the AI models are getting larger and growing quickly. The estimation is by a factor of 20 each year. That's the industry, something recent released estimation. It has triggered a huge demand for computing power, but as more low chip scaling from 12 to 7 to 3 nanometer reaches a point of diminishing returns, the answer is the proliferation of many AI-oriented customized chips, XPU, in super hybrid architecture design. So this design differs from CPU-centric architecture because it's parallel processing by engaging a variety of accelerators, which have proven to have different technological life cycles to be able to follow the rapid evolution of AI algorithms and frameworks. This drives the need for a decoupled hardware design of a clear-cut separation between the serial part of the workflows in head nodes and the parallel section in the form of JBoog acceleration of AI solution. Our customers now are extremely interested to have accelerator delivered in open accelerator OEM form factor, which in addition to advantages discussed here for high density, low signal insertion loss, flexible heat sink design for air and liquid cooling, high voltage power supply, et cetera, do permit them upgrading without revamping the entire server and still taking advantage of the protocol agnostic low latency interconnect, in Inspur case, the release in MX1, which is 6-port hybrid cube mesh or fully connected scale-out topologies of UBB design. So they can essentially eliminate the need for data movement between accelerators via PCIe buses used in the previous design. I'm referring to some of the models mentioned previously in this discussion. So this in this session of so this OEM OAI features are huge differentiator, we believe, and as described in technical details in the other talk earlier today from Gavik Wang of Inspur, which had a talk about an hour ago. Inspur Engineering has invested a lot of resources to meet the challenges and achieve all the design specifications of UBB OAI, like for ICL cyclic frequency, propagation loss, thermal design to permit wide operating temperature from 5 to 35 degrees and so on. On the other hand, the struggle to curb the data explosion by improving deep learning, large model training and inference accuracy have created new theories, and algorithms are constantly developed, which are required to increase the number of model layers or parameters. To cope with and to mimic the way the AI layer deep learning works, for example, we'll need to flexibly increase the number of hardware parallel accelerators without completely changing or revamping the overall design of the AI solution. Here, our customers see another advantage of our Inspur MX1 pioneering product based on OAI OEM design by scaling out to many UBBs connected by low latency interconnects via QSFP DD cables. So to summarize, we're happy to share in this panel discussion 2 practical observations that we can provide as a feedback. First, the OEM design specifications are accepted by more and more manufacturers, and the OEM's accelerator are used now more and more for different applications. Second, most of our tier customers are interested to develop the customized AI system by connecting many UBB models to match with a large but tightly coupled workloads. Clustering UBB models via low latency QSFP DDB cable interconnects, and the previous talk from Intel was very interesting, how they envision to go to the next level on the speed, the latency, etc., the signal loss. I believe it significantly boosts the system performance and can shorten the AI application development cycle and accelerate the commercial deployment, of course, for fast return on investment. So I tried to give us, some feedback on but I took the opportunity, as you see that, to present a little bit more on what Inspur does and how Inspur is involved in. But at the end of the story, Inspur still follows the joint development and manufacturing model, works together with provides the feedback, has joined the OCP and the OAI consortium early on. And at the same time, it works with our customer. We want to set it at the end, we have to deliver a complete solution to our customers. So that's where the challenge. I try to be a bridge, basically find out what are the latest or what is the customer wish list, if you want to call, and digest that first, and hopefully we can provide some feedback to the community, OAI and OCP both. Thank you.
Yeah. Thank you. Thank you, Vango. And let me back to Song. We all see that Intel has been active in the OAI group for defining these OAI and OEM specifications. How are you serving your customers, taking advantage of OAI and OEM? So,
Yeah. So I think the main goal is to solve customer problem, right? And we listen to the customer, right? And then they are looking for a solution and that can handle high power, that can have a topology interconnect, right? And I'm looking for something that like PCIe based plug and play, right? So that's why that and also one of the major requirement they're looking for is like more like common form factor, scalable solution, so that they can have others OEM supplier, right? And using the same system, they do need to go and redesign the whole system, right? And that is how the OCP OAI evolved from the concept into the OCP standard, right? By working with the customer and also OCP community, right? And we just try to want to come up with the solution that is the customer is looking for.
Yeah, thank you. And the next question is for everyone. If you have interest to answer this question, today we introduce a lot of the roadmap and the future of OAI and OEM. And I want to ask what type of things we are working on along with the OAI work streams for OAI, OEM, OAI and OEM next generation. Who can answer this question? What?
Yeah, I can jump in to talk about what is the next thing that we're going to do in the OAI work stream. So I think we used to have the JDA, right? And then we have a bigger group and to a big discussion, right? I think the OAI work stream is more focused on to bring the right talent into the work stream, to stay focused and to get the next generation definition come out, right? And if you look at the accelerated performance, right, it's going to be huge increase for the next generation, right? And we do see that there's a lot of challenges upfront that we have to be working on the next generation. One thing is what I mentioned before is a high speed SerDes, right? The speed rate, right? We are moving from 56 gig to 112 gig PAM4. And also the high power consumption of the OEM module, and that would cause a lot of challenges as well for the overall system, right? Right now we need to, if the OEM itself is a 1 kilowatt, right, you're talking about like 9 to 10,000 kilowatt per system. This is huge amount of the power, and how do we cool it down, right? And then we need to look into the right cooling solution, and also it will impact some of the system architecture as well, right? So that's something that the work stream is going to be looking to, right? And to keep up with the fast pace of the AI HPC application. So by more focusing on the work stream base, right? So I think to keep the right technical expertise in the work stream, I think we can come up with something that is robust, and that the end user or the customer can adopt the standard.
Yeah. Thank you, Song. Who have a supplement? Rob or Vango? Do you have another supplement about this question?
Yeah. Well, I think it's a good question, but it's a little bit difficult to answer, at least from my side, but I can say something. I think this question, in analogy with any new standard or approaches like CAPI, CLX, Gen Z, aim to improve the processor, which are aimed to improve the local near memory as well as fabric attached memory access. You know, they do. I don't think they compete directly with OAI. I mean, they are in different, playing different lines, or because for the designer of data center and their components, dealing with massive amount of data present enormous challenges. One of these is reducing the penalty of data transfer between memory and processors, such as CPUs, system on chips, and GPUs. But as detailed by other panelists, The advantage of the decoupled model between the CPU and accelerators farm of AI 1.0, 1.1 have attracted the support basically from all the vendors, which speaks volumes for the value proposition of this solution in AI industry. Having said that, might be some room for mutual understanding and alignment that the designers of OAI 2.0 might take in consideration in the future. I'm referring from, you know, like kind of a wish list here. I mean, how that will coexist or align itself with CXL, Gen Z, CAPI, and things like that. I understand they play in different roles, but maybe it would have been desirable to have some kind of interface or understanding between, so they will somehow coexist. But in any case, for now, Inspire is focused to take full advantage of and commercialize the current OAI 1.0 for realizing super high density expansion of Inspire MX1 from single to many UBBs, tightly coupled configuration to accommodate large scale AI modeling. So as I said, I mean, the position of Inspire is we're a commercial company. We try to work with both sides, with the users and with the technology providers, but we have to deliver, right? It's like everybody, of course, but we're more facing directly. Yeah. I mentioned here that would have been nice that all this standardization and new interfaces will somehow play well with each other.
Very good. So
Okay.
as
Mark. Rob, your smile. Do you want to answer this question?
It is a difficult question, and what the right next steps are. I mean, in general, the critical areas to focus on are increasing the power and increasing the cooling, and not just having higher signal rate on interconnect, but actually having much more interconnect between modules and between systems. And there are also clear limitations in the bandwidth between the CPUs and the accelerators that, depending on the stage in a neural network execution, can significantly hold up the entire system, and by extension the cluster. So those subtler things will need to be addressed in the next version. And I think also one concern I have, I really like the OAM module, but in our in our work with it, or our examination of how we can use it, there are a lot more components that want to start landing on something like a UBB, and that board is becoming quite dense, and that really means, or it implies to me at least, that the UBB module itself should be a little smaller, so that we can not only pack those tighter and get better signal integrity between modules, but we also free up room for other necessary components.
Hey Rob, Alan here.
Yeah.
You said much more I/O. Could you put a number on a definition of what you mean by much more? A doubled, a 10% more, 300% more?
Are you talking bandwidth or lanes?
Well, you mentioned not just bandwidth. You said it was lanes. You need much more lanes, I think was what I heard you say, if that's correct.
Yeah, I mean, our desire is to, there's a real tension, right? Because SerDes are not free silicon, and they're also not free power. On the other hand, going back to a previous comment, 10x per year expansion in the workload requirements means that, I mean, in principle, you would like to get 10x more bandwidth every year, right? That's not going to happen. So the question is how close can we get to that?
Right. Okay.
Well, how could you benefit from the modularity that we have created? The concept of UBB is that is a connection. That's a tray. That's a platform for multiple OAMs to interconnect. We started with 8, but it need not be 8. It could be 1. Could be 25. So as long as the certain envelopes remain the same, system designers can design to them. As long as software interfaces and management interfaces and security interfaces are the same, variations are quite all right. If the individual OAMs need to have more connectivity, and if laws of physics allow that, UBB specification is not limiting innovations. Things still need to fit in the data center. Yes, there's another law of physics. That's one point. Second point is the interfaces in and out of the UBB itself. For connection to the host, by all means, we need to increase the bit rate. We might need to increase the number of links, and expansion to outside of UBB, outside of the chassis. The expansion modules and that we have defined. QSFP-DD might be a good choice now, but if it needs to change, that's quite all right. That's why we get together and come up with the next version of UBB and next version of OAI. That's quite all right.
Yeah. Now, the kind of responding to some of that, there are some fascinating tensions, right? So as you increase the power and increase the thermal density, that would push you to say, well, maybe I don't want 8 modules. Maybe I only want 4 or some other number. On the other hand, in interconnect physics tell you that actually you want to pack those things as closely as you can so you have high signal integrity and low latency and low signal loss. And so I'm not sure what the industry-wide best compromise is on those things, but I know there's a tension.
One thing we haven't talked about, we have talked about power and cooling. Mass, weight, we have not talked about. So another parameter that we at the data center have to deal with is moving these things. How many people does it take to lift one? And do you need a harness? Do you need a forklift? What do you need to move these things?
Absolutely. In the US, OSHA has a lot to say about that, and it is not a friendly form factor. It is.
Right. Perhaps the point I'm trying to make is that once we have even that as a number, if that is a fixed number, but people come up with clever methods, for example, instead of air-cooled solutions, we go to liquid-cooled solutions. The mass required to cool those elements is much smaller. So we can increase the number of things that fit in the same mechanical envelope. So if we follow the particular standard on weight or mass of UBB associated with all the cooling, the next generation of that UBB can keep the mass the same, but increase capabilities in the performance way, right?
Absolutely. Yeah.
Yeah. Thank you, Rob, Hong, Wangel, and Siamak. The next question is back to end users about the challenges of adoption OAM and OAI solutions. You talk about power and cooling, and like Song told us, in the future, perhaps the OAM will achieve 1 kW. So The question is for Xiaomak and Zhongping. With moving to higher and higher power accelerators, what do you see the readiness for data centers to be ready for liquid cooling, the liquid cooled hardware? I think Xiaomak, you can first.
Actually, if you don't mind, I yield to Zhongping. And I also invite Whitney, if she's online, to join us, because she's our leader here and she's one of the end users of these solutions as well. Whitney, are you there?
Hi, Whitney.
I'm here.
Okay, very good. Good. Now we have the family. Okay, please go ahead.
Oh, I'm okay. Actually, if we're talking about the liquid cool readiness, right? I liked also discuss with Song and Rob, since we're moving to higher and higher OEM, and like these liquid cool studies, right? Starting from maybe NVIDIA, from Song, right? You're gonna push for high power accelerators, and then you will also like need to study these accelerator liquid cool solution. What I'm thinking about the challenge is really like different company, they may have a different solution for the liquid cool. I can give one example, for example, the coolant temperature. And then there are many different like aspects for each company, right? And then how we can work together to do something together, like to have a solution can benefit like everybody, or if not, right, how we're going to deal with this challenge. Let's say we have a solution, liquid cool solution. I mean, the accelerator provider side, they have a liquid cool solution coming out. How they can end user can leverage like what, for example, Intel, NVIDIA has done on the liquid cool solution side, how we can leverage that, or we need to design something new in order to facilitate to our infrastructure. That's kind of like a one of the challenge. And then before even saying the readiness to kind of like embrace this liquid cooled hardware. That's, yeah.
I will add to what Whitney said, and I'll let the rest of the team respond. Again, a very good plug for the modularity that we have created. Before having OAI, before having at least established environment and we can critique and add value, we couldn't have this conversation. Every dimension of the problem was going in a different direction. Masses were different, the number of interconnects were different, the host interface was different, power distribution was different. Everybody was worried about 12 volt versus AC versus 48 volts. We had in every dimension going in different directions. So expanded universe. After having done this OAI now, at least we have anchored on certain pieces. Certain things are known now. Now we can look around and say, okay, which area do we need to focus? Which area can we add value? So in the case of cooling, perhaps, at least we know where the modules are. At least we know how much power we need to take out. And there have been a number of solutions, air-cooled solutions, liquid cold plate solutions. People are even thinking about immersion solutions. So modifying those slightly, it'll be easier this time around. How many manifold pieces you need? Is it better to have an aggregator or have distributed versions of liquid cooling? If it is immersion, we should go after some specifications within the OCP. There's a good community work being done. Material compatibility might be an important factor. As long as we think about these, write down these problems, there are smart people to go solve them, and we go one step at a time.
Yeah, I would say actually already the OCP Advanced Cooling Solutions group has done some phenomenal work, and I'm seeing a lot of quiet alignment with what's going on there. You know, even company, well, I shouldn't even say, so it's companies who aren't even part of OCP are starting to align to some of those things. So this is a really interesting topic, and I've been spending a lot of energy on it the last year. And it's really interesting. Part of the problem is different data centers are now grown up. They're very large, and different hyperscales use different fluids, and they're not that compatible. Fortunately, materials are compatible, but the fluids they're using are not. What we're also finding is that some people have facility water and some people do not. So they need, for example, air or, you know, water to air heat exchangers. And if your ambient temperature coming into a building is, pick your number, 40 degrees C, your water is not going to be cooler than 40 degrees C. So, and other people have facility water where it might be 25 C, for example. So all of a sudden these put incredibly different, they're both quite solvable, but they put very different parameters around the fluid rate, and that tends to mean different diameter plumbing and different quick disconnects and things like that. Another interesting problem is the surface landing and exactly how much heat you have to extract from that. And it's one thing to extract 400 watts from a large die. It's another thing, you know, if we're talking, you know, Song was saying 700 watts or a kilowatt. That's a lot more thermal flux. And that means that the cold plate, for example, needs to be very efficiently mounted. It needs to be perfectly aligned. The TIM material needs to be perfectly applied. That implies robotic assembly, and then assembly and test. So these boards kind of need to be built and tested on their own. The chances of being able to field service something that's dissipating a kilowatt is not great. So these are all really interesting problems that need to be solved. And sometimes I think they really do need to be bespoke for the, as these powers go extreme, and that is the reason why you would do liquid cooling. I think they almost have to be paired. I think they need to be a co-designed solution. They're going to look very similar, but I think they have no, I think they will be different.
Yeah. Thank you, Whitney, Sam, Mark, and Rob. Yeah. Zhongping, you can talk. Yeah.
How we resolve the problem, the cooling is we last year we developed cold plate cooling standards for engineering with another major internet company in China. So now we should try the standard to resolve the problem. Yeah, this is what I can say it now.
Yeah, very interesting discussions, but we have time limit, so we only have one question for one go. As a standard, OEM makes it easier for AI chip startups to deliver high performance AI acceleration models like Inflame. But how do we make it flexible with different types of accelerators? Let's say a new technology shows up with a different form factor from OEM. How would it fit into the OEM and take advantage of the infrastructure? Van Go.
Well, this question, it's pretty difficult from my perspective, from the position of my company, because new accelerators, definitely there are new startups and things like that. Our role is to promote what OBB and OAI and offers as a standard interface for all the accelerators, and to invite them to join this community. At the same time, to make sure that their needs, or whatever they have specific, it is going to be considered by the OAI community. So it goes both ways. We are in between here. We cannot, but at the end, we are not the guys who makes the stand. I mean, we are kind of a bridge between two sides, and of course we present our wishes, if you want to call, our thoughts and things like that. But at the end, it's going to be the community to agree with all these. I mentioned earlier that there are different standards when we come to this large data centers specific for AI that need memory coherency and things like that. And would it be nice if all these efforts somehow converge somehow, or at least they understand each other? I'm making an example here, just maybe it's not exactly, but I mean, there is a mutual understanding between CXL and Gen Z, for example. They are indifferent, but at the end, they try to resolve something similar. I understand that OAI plays in completely different field. Would it be nice if they have an interface in OAI to, let's say, to do some kind of memory coherency, if that makes sense? But definitely it's not the easy thing. At the end, that's where, for example, NVIDIA has its own strategy on this, right? I mean, with acquired Mellanox and things like that, how they will play both. I mean, play with OAI, at the same time, they will try to make the line of implement the vision, what they have to integrate both Mellanox with GPU. So for us, we try to help everybody with our thoughts and be a bridge in between. That's all what I can say.
You're stuck in the middle.
Yeah, I'm stuck in the middle.
Well,
so it's kind of playing midfield here, and you have to play both legs and both foots.
Mangel, we definitely appreciate that challenge that you just mentioned. That was one of the reasons when we first started OAI and specifically UBB. We said these are wires. Wires are wires. We have an OAM. We defined it transmission channels with these physical properties. The protocol that runs on them is up to the OAM, that particular manufacturer OAM, to pick.
That's correct, yeah.
If they pick standard ones, then an OAM from one company and another OAM for another company can be interconnected.
Mm-hmm.
So if one picks PCIe or Gen Z or CXL, if those things are standard, they should play together. As a matter of fact, as we formulated the host interface, we didn't specifically say what it should be. People assumed that it was PCIe. Last year, when we were in Amsterdam, people from IBM joined the conversation, and he said, hey, let it be OpenCAPI. Mm-hmm. We said, by all means, yeah, let's just make sure that that retimer works. And Alan is on the call, and he tells us that, yes, it does work. So, hey, cool, we play. We don't want to discriminate. Whoever is coming up with a wonderful solution, party on. Let's join the party.
Well, that's good. Well, that's good to know.
Yeah. Thank you, Vango. Thank you, Mark. Thank you, Rob, Song, and Zhongping. And thank you, community. Community interconnect your smart people. Make more power on AI accelerator. You let us know how to solve the challenges of machine learning and the future of AI accelerator standards. Thank you again.
I just want to put you know, some wishes here. Maybe we're going to have a quantum accelerator on OAI.
Well, let's just wish that for OCP Global Summit could meet.
Well, there is a company which is doing that. I'm not sure what interface they're doing, but there is a company working for a quantum accelerator.
Right, but let's just have some maybe short-term goals. Hope that OCP Summit, Global Summit, we can meet in person, and hopefully people stay safe and healthy. And basically, what I've just recently learned is the motto that says, "Stay positive, test negative."
That's good. It's very adequate, actually.
Hope we can meet in next OCP Global Summit. Thank you.
Okay, thank you very much.
Thank you, everybody.
Thank you.
Thank you very much.